Okay, we defined the addition of a vector, scalar multiplication, we defined the components, and how can we multiply two vectors? So there are two different ways to multiply two vectors. One of them is the dot product, another one is cross product. So what are the differences? The difference is the dot product is gonna give us a scalar. So once we multiply two vectors, we will get just a number, not just a scalar. But once you do a vector product or a cross product between two vectors, you will get another vector. So let's start with the dot product. How do we apply it? We have a vector A, A1, A2, A3. It's given in a component form, and B is also in the same way. And once you take the dot product, you are multiplying the corresponding components and you are summing them up. So A1, B1 plus A2, B2 plus A3, B3. It's that easy. And for the two-dimensional case, if you have a two-dimensional vectors like that, you will do the same thing. A1, B1 plus A2, B2 is gonna give you the dot product of two vectors. As you can see, you will get a scalar. So for example, this is the vector u, this is the vector v, and let's multiply them. Take the dot product, is gonna be better to say. 2 times 6 plus 5 times minus 2 plus 3 times minus 1, which is -1. So this is, as you can see, this is just a scalar, just a value. So you can think that the dot product tells us what amount of one vector goes in the direction of the another one. What amount of first vector goes in the direction of the second one. So this is gonna give us some scale for that. And this is a vector, it's given in S, in terms of S term. And if you take the dot product of them the same way, S times 3t, 3ts, 5t times minus s, minus 5ts, 3s times minus t, which is minus 3ts, and since these are all depends on ts, once you calculate it, you will get minus 5ts as an answer. And it can be given in terms of the standard unit vectors. So I terms with I terms, j terms with j terms, k terms with k terms. Multiply them and sum them up. 3 times 4, 2 times 0, minus 1 times 5, and the result will be 7. Okay? And the dot product is obeying the many rules that the normal product has. You can check the properties in this slide. It's at the end of the slide, okay? And what else? What is the geometric meaning of a dot product? So we can define an angle between two vectors in terms of the dot product. So here you go, this is A, this is B, and this is the vector between two, this is the angle between two vectors, theta, and we can define the dot product as the length of A times length of B times cosine of this angle, cosine theta. So you need to know this formula very well, you need to remember it. Here you go, if the vectors A and B have lengths 6 and 9, and the angle between two vectors is pi over 3, find the dot product. It's the length of A, 6, times length of B, 9, times cosine of pi over 3. It is that easy, cosine pi over 3 is 1 over 2, the result will be 27. And if theta is the angle between the non-zero vectors A and B, then from this formula you can solve this one for cosine theta. This will be A dot B over the length of A and length of B. So you can easily find the angle between two vectors. Here you go, two vectors are given. The question is asking what is the angle between them. And the answer is easy. Take the dot product over divided by the multiplication of its length. The length of A, 4 square, 0 square, 2 square, which is square root of 20. Length of B, 2 square minus 1 square, 0 square, which is square root of 5. And the dot product is 4 times 2, 0 times minus 1, 2 times 0, which is 8. Then the angle between them is 8 over square root of 100, which is 4 over 5, which is 0.8. So, and from there, if you take the arc cosine of each side, you will see that the angle is about 36.87 degree. Okay. And if two vectors are orthogonal, what can you say about their dot product? you know that if they are orthogonal, the angle between them is going to be 90 degrees. And the cosine of 90 is what? 0. Then the dot product of two vectors, two orthogonal vectors, is going to be 0. So you can check that if two vectors are orthogonal by checking their dot product. For example, these are perpendicular. Show that. How can we do that? We can take the dot product and we can check if it is 0. And as you can see here, minus 1 times 3 plus 2 times 4 plus 5 times minus 1, which is exactly 0. And what can we say about dot product also? Again, if the angle between them is 90, the dot product is 0. If the angle between them is less than 90, dot product is positive. If the angle between them is more than 90, dot product will be negative. Okay? You can also can take this result from the dot product. What about the direction angles and direction cosines? So direction angles is an angle that one vector is making with the positive x, y, and z axis. For example, this is a vector A, and this vector is making having an alpha degree between the x-axis, beta degree between the y-axis, and gamma degree between A and Z. Let's say that these are the direction angles, okay? And direction cosines are the cosines of these angles. For example, cosine of alpha, which is the angle between x-axis and A, is A times, according to the dot product, A is the vector times, and the vector showing the x direction is I vector, standard basis vector, remember that, over the length of A and length of I. Length of I is 1, this is a unit vector, and I is 1, 0, 0, this is A1, A2, A3, then this will be A1 over the length of A. And similarly, you can write it for cosine beta and cosine gamma. And you know the trigonometric identity, the squares of all these cosines is going to be 1. And if you apply that in here, it will be A is A1, A2, A3, and A1 from there, A cosine alpha, A2, A cosine beta, A3, A cosine gamma. If you write that over, and if you factor out the length of A, you will see that A is length of A times the cosines of these angles. And from there, A over the length of A is going to give you the direction cosines of your vector. And so that you can say that the direction cosines of A are the components of the unit vector in the direction of A. This is just the derivation of that. What you need to know is how can we came up with the cosine alpha, cosine beta, cosine gamma. And this is so easy. The angle between two vectors, we are using the dot product definition by the I vector, J vector, and K vector. This is I want you to know, okay? That part. And find the direction angles of the vector A. And here the length of A is square root of 14. Cosine alpha will be 1 over square root of 14. Beta 2 over, gamma 3 over square root of 14. Easily. And from there you can solve it for alpha, beta, and gamma by taking the arc cosine of each of it, and you can find the angles. And the next thing we need to talk about is the projection. Projection of a B vector over Q is the PS, which is the projection of B onto A, this PS vector. So if the vector has a degree less than 90, then this is how you can take the projection of B onto A. And if it is wider than 90, you will get the projection B onto A on the other direction. Okay? And how do we find this? We can talk about the scalar projection and the vectoral projection. The scalar projection is again come up with the dot product. You know that A dot B, if you take the dot product of this one, the length of A, length of B, cosine theta. And for there, this B cosine theta, as you can see, this vector is, this is the B, and this is the B cosine theta component of this vector. This is exactly the projection, scalar projection of B onto A. And if we solve this one, it will be cosine, what is it, a dot b over a. So it's that easy. This is how you can find the scalar projection of b onto a. It is a dot b over the length of a. Okay? And a dot b over the length of a. How can you find the vector projection? Turn this scalar into a vector without changing its direction. So we need to multiply this one by a over the length of a. You know that this is the same vector that has a unit 1, and without changing its direction you can multiply this scalar projection with a over the length of a, and so that you can find the vector projection of b onto a. Okay? So you don't have to memorize, you can just, if you understand the idea behind it, you can easily find it about. Okay? So find the scalar projection and vector projection of b onto a. What you need to do is just apply these formulas. Find the dot product over a is gonna give you the scalar projection. Over a squared times a is gonna give you the vector projection. Okay, make sure that do it with pen and paper, apply it by yourself. And why we are using these projections? We are in general using to calculate it for work. You are not gonna be responsible this part, but I am providing some examples to you in here. So for the work, it is the force times displacement, and this is exactly is coming for the dot product F and F dot B. Okay. So check that out. Again, you will not be responsible for that part.